Hi guys. Okay, so 7.1, the integral as net change. This is actually review, but it's been a couple months, so let me talk it through it with you guys. So fundamental theorem of calculus, there were two of them. The second fundamental theorem of calculus said that if you took the antiderivative and then you plugged in your upper limit and then minus, plug in your lower limit, that gives you basically the area. But then really it's not just the area. So this is the same thing except I wrote f prime instead of little f, right? So same thing, antiderivative of f, and then f has a derivative of this. Okay. So this is not actually area, this is actually the net change or total displacement, right? Because if the area is above and below the x-axis, if that's the x-axis and we're above and below, that negative part is going to be a negative area technically. So it would take a positive and then it would subtract this area. So that's why we call this a total displacement when you take the antiderivative just like, you know, normally, okay? But that would be a total amount, okay? If you know that you have something like, okay, I'll just show you all of it. If you know that you have something like this where it says C is the total, or is the potato consumption of Kansas, where T is the number of years since 1970, and C is in millions of bushels per year. Okay, so this tells me bushels of potatoes, right? Millions of bushels of potatoes. And then T is the number of years since 1970. So T equals 0 would be like the first day of 1970. So January 1st, 1970. So you want to realize that. So we want to know the total consumption from the first day of 1972 all the way to the last day of 1973. So if you're looking for total consumption, then you are, and you know that this is always going to be positive. Like you guys know this is an exponential function. So if this is an exponential function and this is positive and years are always positive and it says plus 2.2, we know that this number is always going to go up and up and up. That function is going to keep going up and up and up. So because it's above the x-axis, we can just plug everything in, find a antiderivative, and then get our total consumption of potatoes. So what would we plug in? Let's see. Well, we want this, so the antiderivative of C of t in terms of t, but what would be your lower limit and upper limit? So I want you to think about that, and then I want you to take a look at this and see if that makes sense to you. So if this right here is t equals 0, then shouldn't this be 2 years later, right? And then really, isn't the first day of 1972 all the way to the last day of 1973, isn't that 2 years? So that should be from 2 to 4. So just like little things like that to remember, and then you put this into the calculator and then you get a 7, but what does the 7 represent? The 7, the C is in millions of bushels of potatoes. So 7 million bushels of potatoes were consumed for 2 years, the 2 years after 1970 all the way to the 4th year after 1970. Okay? Okay, so that was example 1. Example 2 just is a little bit more review. So this is showing you that area that I was talking about, right? So you guys remember you have position, and then the derivative of position is velocity. The second derivative is acceleration. And then when you have a velocity function, when you're above the x-axis, you're either going up or to the right, and then you're going down or to the left, and then you're going up or to the right again. Okay, so above, below, above for the velocity means you're going maybe right, left, and right, or you're going up, down, and up. Okay, so total displacement is just going to be the antiderivative. So the total displacement really, if this area was 15, and this was 10, and this was 5, then it would be 15 minus 10 plus 5, right? Because this is a negative area. Technically, this is negative because it's under the x-axis. So that's why I said a sub 1 minus a sub 2 plus a sub 3. Okay, so you do have to minus this. But when you put it into the calculator, it just calculates for you. What if you wanted the total distance traveled. Well, if you wanted the total distance traveled, so think about it this way, the total distance traveled is you go to the right and you go to the left and you go to the right. You can't just subtract these, right? The total distance is all of this and all of this and all of this. You add them all together. So you would make this positive. So you would add all of those positive areas together. And then how would you do that on the calculator? You would just do the absolute value of the velocity. So if you graph this on the calculator and then you graph it instead with an absolute value around that v of t, you literally put an absolute value in your calculator and then you put that inside the absolute value, then it makes this graph so that this bottom part just kind of jumps up. So you have 3 humps and you'll see that on your calculator, okay? And then that's how you would put it into the calculator to get total distance traveled. So in this next part, it's just a little bit of explanation. I'm not going to read it to you. And then what's the difference between displacement and total distance traveled if this is a velocity graph? What do? We find the little areas, right? We find the little area between the x-axis and the graph. And then displacement would be positive, negative, and positive. So you add them together, you get 1.5. And then total distance traveled would be plus, plus, plus. You add them together, you get 7.5. Okay? And then on the back, there's one question on the back, and it is still review. So let's take a look at it. The velocity of a particle is given, and the total displacement, you're going to find the total displacement, the total distance traveled, and when the particle is moving to the right and the left. So it's been a little while. So let's say this is your velocity function. So what are you going to do? To find the total displacement, let's at first pretend we have a calculator, okay? So, or sorry, pretend we, have a calculator. So if you have a calculator, or even if you don't have one and you're just setting it up, how would you find total displacement? Well, you just find the antiderivative. So you know, from 0 to 6 seconds, you find the antiderivative of the velocity in terms of t, put it into the calculator, you got 204 units, okay? What about total distance traveled? Well, it's going to be the same thing, but with an absolute value. So you put that into the calculator. So I'm going to show you that in a second. I actually need to set it up, but I'm going to show you that in a second. And then how would you find C? So for C, when is it moving to the right and left? So it's been a while, but how do you figure out when the particle is moving to the right and the left? It depends on when that particle crosses when the velocity equals 0, because that's when the particle changes from left to right or right to left. So you have to set the velocity equal to 0, find your zeros, and then factor, and you get plus or minus 2 and positive 1. What do you do after that? Well, for right and left, you need that little number line. So you draw your little number line. Okay, so how do you figure out where you have a positive or a negative? There's 2 ways. So one way is not as efficient. So one way is you look at your factors, and then you pick, like let's say I want to figure out if this is positive or negative. This is a negative 2. To the left of negative 2 is like negative, I don't know, negative 10. So then I plug in a negative 10, I get a negative. I plug in a negative 10, I get a negative. I plug in a negative 10, I get a negative. Negative times a negative times a negative is negative. So I would plug here, I would plug in like a 0. Plug in a 0, plug in a 0, plug in a 0, I get a positive. That's not as efficient. So what's more efficient is if I look at my original function for velocity and I see this is a positive t cubed. Well, a positive t cubed, if this is a positive coefficient, then I'm ending up. So I'm ending up here, so this is positive. And then if I look at this and think about multiplicity and end behavior, my end behavior tells me I'm ending up. My multiplicity, this is a 1, this is a 1, this is the first power, right? And because those are odd powers, I'm going to cross here, I'm going to cross here, I'm going to cross here. So my graph looks something like that. So then I follow my graph. Oh, sorry, it goes like this, and then like this, and then like this, and then like this. So you can see this is negative, and then that'll be positive, and then negative, and then that'll be positive. So that is more efficient, okay, instead of plugging it in. Okay, so now you have this. So C says, when is your particle moving right or left? Okay, your particle is moving to the right between -2 and 1 and between 2 and infinity, right? Right? No, because you're only looking between 0 and 6 seconds. So really, you're cut off right here and you're cut off like right here. So you are between 0 and 6 seconds. So you can't say -2 to 1. You gotta say, oh, sorry. So this part is if you were going to break it up and you didn't have a calculator, you would have to do it this way. Okay, if you didn't have a calculator, and sometimes you don't have a calculator for this, but you would break it up this way, and then you would realize that this part over here was negative, like you would get a negative answer between 1 and 2 when you find the area. So you take that antiderivative. Oh, sorry, that's my rice. My rice is ready. There's the music. Okay, and then that would be negative, so you make it positive, basically, okay, to get your total distance traveled. So then you get these 3 when you plug it into the calculator. I'll show you the calculator at the end. And then you add those together and you get that same answer. So I just wanted you to see that you do get the same answer if you did it by hand, which we technically didn't, but if you had to, you would get the same answer as if you just did that on the calculator, okay? And then, what's your final answer for right? There we go. So not from -2 to 1, but from 0 to 1. Not from 2 to infinity, but from 2 to 6, because we have to stop at 0, we have to stop at 6. Where are you going to the left? You're going to the left between 1 and 2, so between 1 and 2 seconds. Okay? Now I'm going to show you the calculator. So if you don't remember how to plug this into a calculator, I'm going to show you now. If you do, great. So I'm going to go ahead and plug it into my calculator. So I have y sub 1 equals, and then I'm going to do x to the power of 3 minus x squared minus 4x plus 4. Okay, and then I'm done with that, so I'm going to go ahead and quit. So second mode, and I want to plug this into my calculator. So that's going to be math 9 to get to my integral. Some of your calculators are a little bit older, so it's going to be a little different, but you know, we already talked about that in class, so you have to kind of remember, you have to try some things out. But for this one, I'm going to go ahead and plug in from 0 to 6. And then this is the function, this is y sub 1. You're not going to plug that in, that's crazy talk. So y sub 1, there's 2 ways to do it. One way is a shortcut, and I never remember it. So I'll show you the shortcut, and then I'll show you the other way, okay? So the shortcut is alpha trace, and then you press enter. So that's the shortcut, but for some reason, a lot of times I don't remember it. Like every year I have to remind myself. And then right here we have in terms of x. Okay, so I'm gonna press enter. All right, 204, there you go. All right, so I'm gonna go ahead and do this one now. So I go up and I press enter to copy and paste, but I want this to be an absolute value. So I delete this and I need the absolute value first. So to get the absolute value, I use math. So math, I scroll to the right, this is absolute value, press enter. So now I have an absolute value, and then now I want to put in my y sub 1. So my y sub 1, I think of y as a variable. So when I look here, this says variables. So I press bars for variables, and then I want a y variable. So I go to the right, press enter, and then it lists my functions, and I want y sub 1, so there you go. So that is the other way. Okay, I'm gonna press enter, and then this one's a big old decimal, so my calculator takes a little bit longer to think about that answer, but there we go, final answer. And in calculus, in AP at least, we always want to round to the 3rd digit. So we want our thousandth digit, okay? So the 3rd digit. All right. So good luck, and I will see you soon.